Alright class, in this video I'm going to talk about adding and subtracting polynomials. We're going to start off with like terms and figuring out if we can combine these certain examples here. So for the first one, I've already started. I've highlighted the bases and the exponents. They have to be the same, okay? If they're the same, then they're considered like terms. So for the first one, because x and the y's have the same exponential value, they are like terms. The answer is yes. Okay. Let me give you an example of non-like terms, and that's number 2. Notice how x squared in the first one does not match the x exponential value of the second one. So these two terms are not alike. And especially look at the z. This is z to the first power, and this is z to the second. Again, they don't have the same value, so we cannot combine them. So these are not like terms. So the answer is no. The next one, again, look at each part to see if they match. A to the second power. I should be able to see a to the second power on the next one if I wanted to combine them, but I don't. So these two terms are not alike. Again, this is no. The b and both the a's and the b's don't have the same exponent. But C or D, the last one, A times B squared and B squared times A. These are like terms, and let me show you why. For some reason, these people have, used the commutative property to switch it up, but we can also do the same thing. I can go ahead and write A first and B squared. It still doesn't change the value of my term, so this is like terms. They both have the same bases, same exponents, same letters. Everything's the same. They're identical, so we're good to go. So the answer for this one is yes. So big takeaway is when you add and subtract polynomials, you may combine like terms, but do not change the bases. So I'm going to show you an example down below here. So I'm going to go ahead and underline. I'm going to use 3 different colors. So if you are a person that likes colors, this is your time to take out your markers or your highlighters. I'm going to highlight negative 7m to the third power and negative m cubed. And then I'm also going to underline with a different color positive m squared and positive 3m squared and positive 8m squared. And then the last one, let's do blue. I'm going to underline my constants. So I'm going to show you this long version right now. I'm going to use the commutative property so that I can show you how I'm combining. You don't necessarily have to do this every single time, but it's always good to start at the beginning. So for the first one, I'm going to go ahead and combine everything that is alike next to each other. So I'm going to go ahead and bring the negative m cubed next to another like term so that you can see. Again, this step you might want to skip down the road. And then my last one, I have positive 5 and positive 3. So this is essentially what I'm doing. I'm going to go ahead and combine these two terms right here. I'm going to combine my pink terms and I'm going to combine my constants. So if I were to take negative 7m cubed minus m cubed, that's the same thing as negative 7 minus 1. My coefficient is going to be negative 8, but keep the exponent the same. That's the big thing that I'm trying to like the big message with this right here. Do not change the bases. All you want to do is just combine the coefficients. Okay, so I'm not going to go ahead and write m to the 6th power or m to the 9th power. I'm just going to write m to the 3rd power. So the second one, I have positive 3 plus 8. That is positive 11 m to the 2nd power. I didn't combine any exponents there. And then the very last one is positive. So this is my simplified expression. There's nothing else that I need to combine it with. So there you go. Okay. Number 2, I'm going to go ahead and distribute this negative sign Technically, this is a -1 in front, so I'm going to go ahead and dissolve those parentheses in the next step. But I want you to know that you are going to use what you learned at the beginning of the year, use the distributive property to help you figure out the next step. So I'm going to pause this video, go ahead and distribute, and then take out your colored pencils and underline the common terms. Alrighty, so I went ahead and distributed my -1 into my second group here. Notice how all of them, whatever was inside the parentheses, is now the opposite value. So now I'm going to go ahead and combine my like terms. You can go ahead and skip this next step if you don't need it, but I'm going to go here and combine and write down the terms right next to each other that I'm going to end up adding and subtracting. Okay, so I put all the x to the 4th powers together. I only have one term that has x to the 1st power, and my constants are next to each other. Now I'm going to go ahead and line up, I'm going to merge my like terms. So for the first one, I will have x to the 4th power is my base. That's going to stay the same. So all I'm going to do is take 5 and subtract 2 from it. So this coefficient will be 3. My next term is minus 4x, and then my last one is positive 14. So notice how I still maintain my answer in standard form. That is something that you still need to do. Number 1, I had my exponent 3, 2, and my constant 0. You still need to do it for all of these problems. Notice that 4 is my highest degree. This is technically 1, and 14th has a degree of 0. So you have to put them in the correct order. Okay? Go ahead and pause this video and try to figure out number 3. Make sure that you underline terms that have the same degree. Okay, so here is my answer. I just took them out of the parentheses and I've underlined the like terms with the appropriate colors, and now I'm going to go ahead and combine like terms. So here is my final answer. Notice how my exponents and the variables still stay the same. All I did was combine the first numbers. And then this is 5xy minus 1. So really it's 5 minus, oops, that should be a plus. Oops. Let me fix that for you guys. It should be a plus 4, sorry about that. 5 minus 1 is positive 4xy. And then we have minus 7. Okay. So try the next one, and then check back with me. Alright, so here I've just dissolved the parentheses because really I'm distributing 1 to everything, so everything's still the same. But I've underlined the appropriate colors. I'm going to go ahead and start combining my highest degree because I need my answers in standard form. So I'm going to go ahead and let's start with this pink one. I'm going to combine the pink, then I will combine the green one, and then I will combine the yellow, and then finally the purple. So this is what my final answer will be. Alright, and there's my answer. Combined all my x cubed times y to the 4th powers. Combine them all together. I combined, there's only really one of these, so I didn't have to combine it with anything. Same with the yellow one, -7x cubed. But I did combine -2x and -3x. Notice that there is no new exponents. They're all the same from the original problem. Alright, so last but not least, we have these types of problems. It's basically applying what you know. We've talked about this when we were doing systems. Well, perimeter, really what you're doing is you're adding all your sides together. There is a formula that could be helpful, and that is taking the 2 lengths, multiplying by 2, and then adding that to the width times 2. So in this case, it's the same type of problem. We want the answer in simplest form, so we are going to be combining all of our terms together. So here we go. Perimeter equals 2 times the length. Well, we can go ahead and make this one L and this one W. It doesn't really matter because these are interchangeable. So we'll put 5x minus 7. And we're going to add add 2 times my width. Let's use that a different color here. let's make this one blue, negative 2x plus 6. And then, oops, I want to use orange. No, yeah, orange. That's basically my equation. Yeah, I'm going to go ahead and try to change the color of the length here. I'm going to change it to a different color just so that you can see where it's coming from. Let's make a length green. Alright, so 5x minus 7. And all you have to do now is distribute. And then combine like terms. So this will be P equals 10x minus 14 plus, oops, not plus, should be negative, or minus 4x, because 2 times negative 2x is negative 4x, plus 12. So again, we are just combining like terms. We have 10, negative 4, and negative 14, and 12. So if we were to combine those together, my perimeter is 6x minus 2. Okay? And we have the last question. We are going to, it says, consider the following key. What is the polynomial in simplest form that is represented by the following? So each positive, or every white square is x squared. Every shaded in, you're going to actually subtract by 1. Or sorry, you're going to subtract 1x squared. And yeah, we're going to combine like terms here. So I'm going to go ahead and fill in the values of each of these squares. So I have written down the numbers of the value of each square. So now you combine. There are 3x squares, so that is the coefficient of my first one. I have negative 4x, and I have positive 3x. If I were to combine those together, my answer is negative x. And I have negative 1, minus 1, minus 1, minus 1, minus 1, which gives me negative 5. So really, you're just using all the key to help you, and then combine like terms. So hopefully this video has enlightened you on how to add and subtract polynomials. Let me know if you have any questions. Make sure you only combine terms. The coefficients, do not add the exponents. That only is when we're multiplying. Okay, so if you have any questions, please let me know. Okay, bye.